Good evening, dear students. Welcome to preparation strategy for TS GENCO. Regarding RCC and PSC, my dear, I have prepared a few questions, related questions you can expect in exam. Okay? Yeah. First of all, weightage. Audible? Good evening, dear students. Welcome to TS GENCO preparation strategy and few questions related to the main exam. Okay, right. Subject RCC and PSC. My dear, weightage in GENCO, my dear, 4 to 6 questions you can expect in exam. Okay. Coming to the syllabus. Check the syllabus once. Limit state design. Limit state design for bending, shear, axial compression and combination, that is combined forces, design of beams, slabs, lintels, foundations, retaining walls, tanks, staircases, principles of prestressed concrete design, including materials and methods. Coming to the next one, earthquake resistant design. My dear, it is not a chapter, it is a subject. You need to spend more time. That too, chances are very less to get question from this area. Okay, and design of masonry structures, even from this area also very rarely questions are asking. So no need to cover these two topics. Rest of the topics you need to cover sufficient. Okay, fine. Here they have not mentioned working stress method, but they are asking questions from working stress method also. Okay, right. I will take here few related questions for the exam. Mostly sometimes same questions also appeared as it is. Okay, right. Now preparation strategy. In this subject, you can give first priority for codal specifications. Can give first priority for codal specifications. 90% of the questions will come from codal specifications. The rest of the 10% of questions will come from definitions as well as from concepts. Okay, right. After codal specifications, my dear, give priority for definitions. After that, give priority for concepts. Codal specifications like cover for beam, for slab, for footing, for column, right? Then definitions like effective depth, shear span, right? Like that. Concepts in beam, if you increase the steel, then what about depth of neutral axis? In balance section, which material fails first? Right? This type of questions, concept related questions. Okay? Fine. We will see all model questions here. Come to the question number 1. Working stress method is a, my dear, in the syllabus they have not mentioned directly working stress method, but tanks will be covered under working stress method. So definitely that basics you need to understand. Okay? Working stress method is a, options given, stress governing method, strain governing method, both A and B. D, neither A nor B. My dear, in working stress method, failure of material is decided based on stress. It is decided based on stress. Hence, we call it as a stress governing method. Working stress method is stress governing method. Whereas, limit state method is a strain governing method. Limit state method is a strain governing method, because we decide failure of material based on strain. Okay, na? Right. Working stress method is a stress governing method. Suppose if they ask a limit state method, then you can pick up strain governing method. Okay? Fine. Next question. The factor of safety in RCC used for steel and concrete in elastic method. Elastic method refers to working stress method. Working stress method. Okay. In working stress method, factor of safety used for steel and concrete. For steel and for concrete. For steel it is 1.78 and for concrete it is a 3. Okay. Suppose if it is a limit state method, we don't say factor of safety, we can say partial safety factor. Partial safety factor for steel 1.15 and for concrete it is 1.5. Okay, right, 1.15 and 1.5. But here working stress method, elastic method na, so which refers to working stress method. 1.78 means nearly 1.8. 1.8 and 3. Option C is correct. Okay na? Right. I hope you will also answer. Yes. Syed Yunus, sir, discuss subject-wise marks, weightage. Mr. Syed, however, I am taking a preparation strategy in the same way. Every subject, they will give first a weightage and syllabus, then they will move on to the questions. Okay, na? Right. So, better if they discuss other subjects by other faculty members. I think it is better. Regarding my subject, I am telling. Okay, Mr. Syed? Okay? Comfortable? Right. Okay, ma. Then move to next question. Even if you follow these questions, I am telling you, mostly 2 or 3 questions you will expect from these questions itself as it is. Okay? Right. Next one, modular ratio of M20 concrete is. Okay. Modular ratio in elastic method, we can write 280 upon 3 sigma CBC. Generally in strength of materials, modular ratio you can write ES upon EC, right? But in working stress method, we are not going to write ES upon EC. We can write 280 upon 3 sigma CBC. I think it is better if it is mentioned in elastic method, so that clarity will be there. Okay, right. Here given M20 grade concrete. For M20 grade concrete, permissible bending compressive stress in concrete is 7 Newton per mm square. Okay, let us substitute here. It is 280 upon 3 sigma CBC 7. So you will get 280 upon 3 into 7, 21. For exam, calculator not allowed, not permitted as per my knowledge. So it is difficult to simplify 21. So I can take nearest value as 20. Okay, just approximate value I will get it. 0, 0 gone, 2 1s are 2 14s are. So answer will be very close to 14. Is it more than 14 or less than 14? My dear, here actual value is 21, but I have taken lesser value. If I take lesser in denominator, I will get more value. So answer is less than 14, but very close to 14. Less than 14, very close to 14. Only one option is there, that is option D. Very, very important in competitive exams. When they are not going to allow calculator, we need to simplify numerical problems by going approximations like this. Exact value will be different, but simplification is very, very difficult. Okay, in the examination hall, we need to spend more time. to save the time, you can go for approximations. Not only this subject, any subject you can take it. Okay? Better if you take approximations, very close to that value is your answer. Okay, na? Fine. Next one. When earthquake or wind load is taken into account, the permissible stresses in working stress method are increased by. Actually, in IS 456-2000, given permissible stresses in concrete, page number 81, table number 21. This is permissible stresses in concrete. Page number 82, table number 22. Permissible stresses in steel. Table number 22, given for permissible stresses in steel. Table number 21, permissible stresses in concrete. These permissible stresses, you can increase further by 33 into 1 by 3 percentage means 33.33 percentage you can increase. That means you have to multiply those stresses by 1.33. When, my dear, generally dead load and live load are present. Along with this loading, if wind load or earthquake load is coming to picture, in this case, you can increase the permissible stresses in concrete as well as in steel by 33.33 percentage for economical design. Okay, we do that for economical design. Option A is correct. Okay, let us move to next question. The effective depth of singly over reinforced section is 300 mm with the neutral axis at 120 mm below the top. If the maximum stress induced in the concrete is 5 megapascal and the modular ratio is 18, the stress developed in steel would be, okay, here given effective depth, how much it is? 300 mm. Fine. And depth of neutral axis, they have not mentioned whether it is actual depth of neutral axis or critical depth of neutral axis. They didn't mention in the question. Okay, let us take x. X equal to 120 mm. If the maximum stress induced in the concrete is 5 megapascal, stress in concrete, maximum stress given 5 megapascal. And modular ratio given 18. Modular ratio given 18. Then what may be the stress developed in steel? What is the stress developed in steel? My dear, if they ask this type of questions, better you can draw the stress diagram. Then it is convenient for you. Okay? Fine. Stress diagram for a singly reinforced beam looks like this. Maximum stress in concrete, let us write C. Stress in tension steel, write T. But we have to write stress in steel in terms of concrete. So T by M. Okay. Now join these two stresses. Fine. My dear, this is a neutral axis and it is the depth of neutral axis x and it is the effective depth of the beam D. They are asking to find T value. If it is x, then this depth will be D minus x. This depth will be D minus x. Okay? Good. Now, use similar triangle. Use similar triangle property. Use similar triangle property. That is T by M upon C equal to, for this stress, what is the distance? D minus x. For this stress, what is the distance? X. Now, T by M given 18, C given 5, D given 300, X given 120. Upon 120. Now, T equal to what? T equal to, from this, it is 180 upon 120 into, it is 5 into 18. Okay. My dear, simplify. 0, 0 gone. 6 2s are 6 3s are. 2 1s are 2 9s are. 9 5s are 45. 45 3s are 135. So this value will be 135 megapascal. 135 megapascal, right? Here options given 130, 135, 150, 180. Yeah, option B is correct. I suggest to all of my students, while attempting questions 1, 2, 3, 4, 5 up to n in question paper, n number of questions will be there. How to approach? Very simple. Read question number 1. If you know the answer, pick up. If you don't know the answer, leave it. Move to next question. That means without putting pen, we have to pick up the options. If you do like that, you will touch all the questions. Maybe it will take half an hour to 40 minutes time. What you are doing? You are reading question, you know the answer directly. Maybe you have seen a similar question in classroom, or you have seen similar question in test series, or you have seen a similar question elsewhere. You know the answer for that. So pick up that type of questions. Okay. Let us say it is stage 1. Whereas stage 2, we know the approach for a numerical question, but it will take at least 1 minute time, right? 2 to 3 steps we have to write. That type of questions you can try in the second stage. That means you have to read once again question paper. Which questions already completed? No need to read once again. Okay, fine. So next 2 to 3 steps. After that, you try, my dear, lengthy questions. You know the approach, but the solution will be lengthy. That type of questions you can try in third stage. In fourth stage, you have to cross check how many number of questions you have attempted, whether you have picked up the option correctly or not. You check it once. My dear, if you try like this, at the end of the exam, you will not leave easy questions. Some students, they will solve question number 1, next question number 2, next question number 3, like that. They are not going to, my dear, skip the questions here. Simply they are going to follow the sequence. That is not a best method to attempt more number of questions, to score more marks. That is not the best approach, right? According to me. Come back. Why I said that? See, here you have to take at least 1 minute time to solve this question. Correct now? For simplification, etc., etc., you need to take 1 minute or more than 1 minute sometime. It depends on your speed of calculation. So better you can try easy questions, which means you know already the answer. Without putting pen, we can able to pick up like formulas, definitions, standard values, this type. Then next, second, like moderate type. We know the approach, but it will take 2 to 3 steps. Next, moderate only, but number of steps will increase. Or you can consider too much lengthy difficulty question. Okay? Right. Next, last stage, last 5 to 10 minutes, you have to dedicate to cross-check how many number of questions you can able to answer, and also whether you picked up the right option or not. Just dedicate last 10 minutes for that. Okay? Right, my dear. Here, I think some of you are raising doubts. Anybody? Don't you get bored, sir, teaching same stuff day by day over the years? Koti. Yeah. Mr. Koti, I think you are writing by this time same exam 10 times or more than 5 times. If you are not getting bored, then why faculty members will get bored? Right? Because same level of questions only will ask in exam. What type of questions will ask, that type of questions we need to discuss. If you like it, you listen. Otherwise, you just relax. You prepare something else. Why do you waste your time, Mr. Koti? Even if it is after 20 years also, I will take the same concepts, same questions, because syllabus will be like that, questions will also come like that. We have very good experience in this, right? We know what type of questions will come. I don't think that to take suggestions from your side. Okay? If you like it, you can stay. Otherwise, better you can. Okay? Please. If you know the answers, you have to answer. Otherwise, better. Okay? Right. Next one. In a singly reinforced beam, if the stress in concrete reaches its allowable limit later than the steel reaches its permissible value, the beam section is said to be. Good question. Most of the time we confuse this type with this type of questions. Right here they have used the word later. So easily we will confuse. Later, they have used the word later. Okay? Right. Here, stress in concrete reached its allowable limit later. That means what? Stress in concrete not reached to its permissible stress. It is less than permissible stress. Stress in steel reached to its permissible stress before the stress in concrete reached to its allowable limit. My dear, the stress in steel reached to its permissible limit. This type of section we call it as under reinforced section. Okay? Right? Fine. Option A is correct. Option A is correct. Option A is correct. Okay, na? Right. Next one. Flexural collapse in over-reinforced beam is due to. Flexural collapse in over-reinforced beams is due to. Options given: A, primary compression failure, B, secondary compression failure, C, primary tension failure. Right? Okay. Option D given bond failure. It is not at all related to this question. My dear, here flexural collapse, that means it is one kind of failure under bending moment. Different modes of failures we have seen in class, right? Under modes of failure, my dear, due to bending moment, we have balance section, under reinforced section as well as over reinforced section, right? Yes. Here, primary tension failure you can expect in under reinforced section. Here, tension failure, Steel fails first in under reinforced section under tension, right? So it is a tension failure. Primary tension failure, because of the bending moment, failure occur in steel. That is a primary tension failure, okay na? Right. Next one, secondary compression failure. My dear, it is not due to bending moment. It is due to secondary effects like shrinkage, creep, temperature variations, etc. Okay? Right. Then primary compression failure. Primary compression failure, yes. This primary compression failure you can expect in over-reinforced section. That too under bending moment, the compression failure takes place. That's why we are going to consider here over-reinforced section failed under primary compression failure. Okay? Option A is correct. Option A is correct. Okay na? Right. Fine. Next question. Be ready. Doubly reinforced beams are preferred. When do you prefer a doubly reinforced beam? My dear, while I am explaining the solution, I am not only explaining the question, background concept also I will explain. Need not be worried. Okay? Right. Doubly reinforced beams are preferred when? My dear, there are different situations to prefer a doubly reinforced beam. One is when the size of the beam is restricted, maybe architecture point of view or a headroom point of view. And when the beam is subjected to reversal of stresses, then when beam is subjected to impact load, then at intermediate supports to counteract hogging moment, we can go for a doubly reinforced beam. Not only for this, even to increase the ductility of the beam, we go for a doubly reinforced beam. My dear, to get higher ductility also, we can choose doubly reinforced beam. Here options given when the depth is restricted due to headroom, etc. When there is a chance for a stress reversal along the length of the beam. C, both A and B are correct. D, none of the above. My dear, option C is correct. Both A and B are correct. Both A and B are correct. Okay? Right. Next one. Depth of neutral axis for a doubly reinforced section is 20 centimeter. Yes, X is equals to 20 centimeters. They have given clearly. The compression steel is being placed at 40 mm below the compression edge. So, effective cover given to the compression steel is 40 mm. If the maximum compressive stress in concrete is 5 Newton per mm square, this is 5 Newton per mm square. Modular ratio given M equal to 15. Stress in the compression steel is given by. Wonder what is the stress in compression steel? Beautiful question. It is a stress diagram. Okay. My dear, here is the maximum stress in concrete. At this level, we place the compression steel. Here is the stress in concrete at the level of compression steel. Okay, it is a neutral axis. My dear, it is the effective cover to the compression steel. And it is the depth of neutral axis. Okay. To find stress in compression steel, we must know the stress in concrete at the level of compression steel. Okay, we'll see here. What is this depth? It is X minus D dash. Okay, na? Again, you can use similar triangle property. From similar triangle property, I can write C dash upon X minus D dash equal to C upon X. What is C dash here? We have to find C dash upon. What is the X? Depth of neutral axis given 20 centimeter. Better you can write in mm because here options given in Newton per mm square. Megapascal means Newton per mm square. So you need to convert everything in Newton per mm square. It is 200 mm. 20 centimeter given, you can write down it is 200 mm. 200 minus effective cover 40, which is equal to C, stress given 5 upon, what is the X, depth of neutral axis 200. Okay. From this we can get C dash equal to 5 upon 200 into this 200 minus 40, 160. My dear, 0, 0 gone. Okay. It is 4 5s are, 4 4s are. Now 5 5 gone. You'll get 4. What is 4? 4 megapascal is the stress in concrete. But the question is not stress in concrete. Question is stress in compression steel. Okay. My dear, stress in compression steel will be 1.5 m times C dash. 1.5 m, m given here 15. C dash we are getting 4. So 15 4s are 60. 60 into 1.5, 90. 90 megapascal. Stress will be 90 megapascal. Option D is correct. Okay, na? Right? Option D is correct. Come on, my dear. Tell me. Here, do you have any doubts in this? I think right. Nobody raised the questions here. Anyone? Anyone? Okay. Fine, my dear. Yeah. Next one. Equivalent area of steel in compression is, my dear, it is a tension steel area. For tension steel area, equivalent area will be M into AST. For compression steel, equivalent area will be 1.5 m minus 1 into ASC. Here, the question is for compression steel, a steel in compression zone. Maybe in exam they may ask steel in tension zone. At that time, equivalent area will be M times AST only. Okay, right. So 1.5 m minus 1 into ASC, option C. Option C is correct. Okay, right. Next one. The stress strain curve of the concrete as per IS 456-2000 is, my dear, options given: A, perfect straight line up to failure; B, straight line up to 0.002 strain value and then parabolic up to failure, right? Then parabolic up to 0.002 strain value and then uniform up to failure. D, linear up to 0.002 strain and uniform up to failure. My dear, for a design and analysis purpose, we can use ideal stress strain curve. Okay, it is partly parabola, then partly rectangle. So it is for a cube, we take FCK. Now strength of concrete in a structure will be 0.67 FCK. But for a design purpose, we take it, my dear, for a design, it is 0.446 FCK. It is 0.0035. Here they asked question, what will be the stress strain curve of the concrete as per IS 456-2000? My dear, it is parabola. Parabola up to what? This is parabola. Parabolic shape. From here to here parabola. Then rectangle. Up to which strain it is parabola? 0.002. Beyond that it is constant. Okay. It is parabola up to 0.002 strain value and then uniform up to failure. Yes. Option C is correct. Okay na? Right. Here any doubts? Pravallika. Hi sir. Hi ma. Right. Please. Same questions you can expect in exams. You can check once the previous year papers, my dear. We know what to teach. Right. I am not only discussing same question related to that. My dear, how they are going to ask questions also I am explaining here. Okay. Right. Like this only questions will ask. That's why I am taking the similar questions only I have selected. Okay. In LSM of columns, the partial safety factor applied to steel and concrete are. My dear, not only for columns. This LSM is not only for columns. Even we can use for beams, we can use for slabs, we can use for footings, we can use for staircases also, right? Okay. Limit state method applicable for all structural members. So, partial safety factor used under limit state method, my dear, for concrete 1.5, for steel 1.15. Yes, damn sure. You will expect this question, right? 1.5 for concrete and 1.15 for steel. Option C is correct. Option C is correct. Okay? Right. Moving to next question. If the characteristic strength of concrete FCK is defined as the strength below which not more than 50% of test results are expected to fall, the expression for FCK in terms of mean strength FM and standard deviation S would be, my dear, concentrate. Right. Y-axis we take frequency and X-axis we can take strength. It is normal distribution curve. Up to midpoint we can take it mean. Right. If you take only 5% of test results only expected to fail, then we can write this hatched portion is FCK and this part will be 1.65 times sigma, which is equal to Fm. We can write from this FCK equal to Fm minus 1.65 times sigma. This is the relation. Okay. But in this question they have not given 5%, they have given 50% of test results. For 50% of test results, it is strength, x-axis we can take strength, then y-axis we can take frequency. Right, midpoint we can take it as a mean. Okay, my dear, 50% of test results. Okay. From here to here, let us take, my dear, FCK, hatched portion. Up to midpoint, you can take it FM. So, for this case, FCK equal to FM. Suppose if they give 5%, my dear, then Fm minus 1.65 times sigma. But here given 50%, so option C is correct. Okay, na? Option C is correct, right? Okay. Next. The maximum strain in the tension reinforcement in the section at failure shall not be less than. One question compulsory based on the strains. There are different strains. All the strains I will take right now. See here. First, strain in concrete. It is 0.0035. When do you consider this? It is under bending moment. Under bending moment, the strain value will be 0.0035. This is a maximum strain in concrete at the time of failure. Maximum strain in concrete at the time of failure. And one more, strain in concrete, 0.002. Under axial force or axial compression, the maximum strain in concrete will be 0.002. Okay, right. Next one, my dear, maximum strain in concrete 0.0035 minus 0.75 times epsilon m. It is under bending moment and axial compression. In a member, if both are developing axial compression as well as bending moment, it is possible in columns, right? For that case, maximum strain in concrete will be 0.0035 minus 0.75 times epsilon m. There is one more strain, that is shrinkage strain in concrete. Shrinkage strain in concrete. Wait. Shrinkage strain in concrete. It is 0.0003. Shrinkage strain in concrete, my dear. Or you can write it is 3 into 10 to the power of minus 4. You can write under pre-tensioning, even in RCC also, right? In both cases, the steel will be directly in contact with the concrete. There is one more strain, that is shrinkage strain only. Shrinkage strain in concrete. It is 2 into 10 to the power of minus 4 upon log base 10 into T plus 2. This is under post-tensioning method. Under post-tensioning method. Shrinkage strain in concrete. And one more thing. Strain in tension steel should not be less than 0.002 plus 0.87 Fy upon Es. And one more, strain in compression steel will be, my dear, it is 0.0035 into 1 minus d dash upon xu or xu max, it depends on the type of the section. Out of these strains, 1, 2, 3, 4, 5, 6, 7, you will expect one question. You will expect one question. Okay, right. Here question is strain in tension steel, tension reinforcement. Okay, it is 0.002 plus 0.87 Fy upon Es. Yeah, option A itself correct. No need to move to another options. Okay, na? Right? Fine. Next one. For steel of grade Fy equals to 500 Newton per mm square, the value of xu max upon d, my dear, xu max equal to 0.0035 upon 0.0055 plus 0.87 Fy upon Es into d, 0.0035 upon 0.0055 plus 0.87 Fy upon Es into d. Here XU max depends on only steel grade. XU max depends on only steel grade. Okay, D is a constant. D effective depth which is constant. So maybe we'll expect question, limiting depth of neutral axis depends upon grade of steel only. And what is the value of XU max? It depends on grade of steel, na? So XU max equal to 0.53D, 0.53D for Fe 250 grade steel. XU max equal to 0.48D for Fe 415 grade steel. XU max equal to 0.46D for Fe 500 grade steel. Okay. Here given Fy equals to 500. If you substitute Fy 500, E value 2 into 10 to the power of 5, you will get 0.46D, right? Option, they are asking XU max upon D. So option B is correct, 0.46. It is 0.46, okay na? Right. Next one. Side face reinforcement is provided in a beam when the depth of web exceed. My dear, there are three different cases. Depth of web more than 750 mm, depth of web more than 450 mm, depth of web more than 500 mm. My dear, in pre-stressed concrete, if depth of web more than 500 mm, we will provide side face reinforcement. Okay. If beam is subjected to torsion, if depth of web is more than 450 mm, let us provide side face reinforcement. If beam is subjected to only bending moment, no torsion in RCC, provide side face reinforcement. When depth of web exceed, these two are in RCC, this one will be in pre-stressed concrete. If you read this question, my dear, side face reinforcement is provided in a beam when the depth of web exceed. Here not mentioned pre-stressed concrete, not mentioned RCC, right? Even they have not mentioned whether beam is subjected to flexure or beam is subjected to torsion. In this case, let us consider general case, that is 750 mm. Okay na? Suppose if it is pre-stressed concrete, 100% they will mention in the question, but they have not mentioned, so it is not related to PSC. Even if it is torsion, beam subjected to torsion, they will mention in the question, but they have not given. So in this case, my dear, you can consider 750 mm. Option D is correct. Okay, right. Moving to the next one, next question. As compared to working stress method of design, limit state method takes concrete to options given: A, higher stress level; B, lower stress level; C, the same stress level; D, sometimes higher but generally lower stress level. Here students will confuse while comparing. Maybe they fail in understanding of question. Here they are comparing two methods, working stress method and limit state method, comparing two methods. Here, my dear, understand, as compared to working stress method, it means the question is regarding limit state method. The question is regarding limit state method which is comparing with the working stress method. Okay na? They are talking about stress in concrete. Stress in concrete. Let us take design stress. Design stress will be sigma CBC here. Sigma CBC is FCK by 3. Here design stress will be, my dear, 0.67 FCK upon partial safety factor for concrete is 1.5. If I simplify this, I may get 0.33 FCK. If I simplify this, I may get 0.446 FCK. Now compare. You just see this side. Limit state method is your object. Okay? You are comparing this with this one. Now what about the stress in concrete? Higher or lesser? Higher. Sometimes what they do now, they keep limit state method here as compared to limit state method of design. Working stress method takes concrete too. Like that it will be given. So be careful. Don't fail to understand the question. Check it. Here as compared to working stress method. Okay na? Right. In limit state method, concrete takes a higher stress level. Option A is correct. Okay, right. Next one. Next one. Yeah. XU by D is a greater than limiting value of section is designed as a, see my dear, XU by D greater than limiting value. They have not mentioned limiting value. We know limit will be for XU, limit will be XU max. So, XU by D is a greater than XU max by D. My dear, if it is a case, we consider it is over reinforced section. XU by D less than XU max upon D. Then we will consider it is under reinforced section. XU by D equal to XU max upon D. Therefore, it is a balanced section. My dear, we can prefer to design either balanced section or under reinforced section. They are not asking here if XU by D is a greater than limiting value, then which section is it? That is not a question. Question is, you will design as. My dear, we don't design. It is over reinforced section. It is over reinforced section. Okay. So, nature of failure is sudden. That's why we will avoid to design this. We don't recommend. We can go for redesign. We will go for a redesign. Okay, na? Fine. My dear, is it audible to everyone clearly? Is it audible to everyone clearly? Please respond. Sweta, good evening sir, very good evening ma. Is it audible ma clearly? Is it audible? Yes or no, dear students? Okay, fine, no issue. I hope it is audible clearly, right? Because some students asking here, sir, good evening, like that. That's why I am getting doubt, okay? Fine, 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 fine. Okay, my dear. Come back. Next question. Next question. The minimum tension reinforcement of Fe 500 steel in a 250 mm wide beam of 400 mm effective depth is, right? My dear, minimum steel very, very important in beams, in slabs, in columns as well as in footings. Footings no problem because it is same as that of slabs, okay? So, take care. Minimum steel in beams, minimum steel in slabs, minimum steel in columns. One question you may expect, maybe from beams or from slabs or from columns. Okay, that is AS upon BD equal to 0.85 upon Fi. It is the minimum steel in beams. In beams, minimum tension steel. In beams only, minimum shear reinforcement formula available, that is ASV upon B into SV should be greater than or equal to 0.4 upon 0.87 Fy. Okay. And my dear, next, in slabs, minimum steel will be 0.15% of BD and 0.12% of BD. Right. In columns, minimum steel will be 0.8%. In columns, minimum steel will be 0.8%. Right. Okay. Come on. Right. So here they have given one numerical question. Minimum tension reinforcement AS upon BD. B it is 250. D it is 500, which is equal to 0.85 upon 0.85 upon Fy. Fy is for Fe 500 grade steel, it is 500. Okay, let us simplify. 500 gone, then 250 is remaining, right? Yeah, it is 250. Now, AS equal to 0.85 into 250. You simplify it, you can get the answer. Okay. Here I am decided that due to time constraint, my dear, due to time constraint, here only I can do it. See, from IS code, please check it. Minimum cover. For what? For beams, for slabs, for columns, for footings, you can check it. Okay. Go through once. It is 25, it is slabs, my dear, 20, columns 40, special cases will be there, you go through once. Footing 50. Next one, minimum steel. Minimum steel in beams, slabs, columns, footings. Then maximum steel. Then minimum diameter, minimum or maximum diameter, whatever recommended by IS code. Okay. Mainly you can focus on this. One question compulsory from this. Okay, na? Right? Fine. Next one, you focus more and more on these chapters because these are the basic chapters. Singly reinforced beams in limit state method, then shear, then slabs, then columns. Mainly you have to focus on these chapters. Chances are more and more to ask questions from these 4 chapters. Okay, right. Coming to the pre-stressed concrete, my dear, you can give first priority for losses, next give priority for fundamentals. Still, if you have a time, then give time for analysis also. I have explained already in class. My dear, just to go through once. If you have any doubts, you can contact to this number. Due to time constraint, I am not going to explain the rest of the part. Okay. My number is available with you, right? Anyway, once again I am giving. It's a contact number only to clear your doubts, please. You try it. Okay. Once again I am telling you, questions will ask in this model only. If I tell a question from IS or question from GATE or question from civil services which is not given for AW, what is the use with that? Do you catch my point? One student raised this point, why do you take, sir, always same type questions? Reason is so simple. Questions will ask like this only. We can't change. If they change, my dear, code, then there is a possibility, right? But they don't change code. Concepts will be like that only. So questions will also ask like that only. Okay? Go through once my notes, my dear. If you have any doubts, happily you can contact. Okay? I wish you all the best, ma. Right. So once I will check out, once any doubts will be there, please let me contact my dear students. Doubts? Either Adarsh Gaud, Prashant, Sweta, Raghavendra, Anurag, Koti, then software, Syed. Tell me, ma. Okay, dear students, have a nice day. All the best. Huh? I wish you all the best. While preparing also, if you are getting any doubts, yes, you can. If you attend my classes, I don't think that once again required a special, my dear, especially once again, a revision also not required. I think you can attempt the questions easily. Okay? I wish you all the best.